we start the recording for today. So because no aircon, so we'll feel warm a little bit. So we are now in EGR 3214, engineering statistics. Make sure you already passed this module. Mathematics 1, engineering mathematics. Yeah. Okay. This module, you require to do simple differentiation. You know what is differentiation? You need to know how to do simple differentiation and also integration. So if you are weak in that area, do a lot of revision. No worry, this module I will give you a lot of question. Some question you can come to my office to get the answer, but I'll give you a lot of example in the class. Okay, so this is a lab precaution. So you already know, most of you are in your second semester. You did your lab session last semester. So third semester one, you already know what you should do in the lab. Please wear cover shoes and long pants to protect for safety reason. For safety reason. Okay. So if you log into Canvas, you'll see there's a document called course structure. So you can download, but course structure is a bit lots of information there. So what does engineering static do? You will look at object that in the motion or without motion. But one main thing, what is the difference between engineering statics and dynamics? Statics, one keyword is you have a constant velocity. Constant velocity. But after you pass this module, you will look into dynamics, which is you don't have a constant velocity problem or question anymore. That means the object will continue to move and it will change acceleration. So I hope you're familiar with the physics terms, for example, velocity, acceleration, and all this. So all the module will be the same. You have a learning outcome. So there are 4 learning outcomes for this one. Why this one is important? Because this will be how we set the exam question for you. It will be either in your test 1, test 2, or final exam. Okay. So your test 1 will be cover CLO1 and CLO2. This one will be question 1. This one will be question 2. Okay. So CLO1, we look at equilibrium. In your SPM or STPM or matrix, you heard about equilibrium. Means all the force equal to 0. All the force equal to 0. Or all the moment equal to 0. So this one. Second one is you look at internal force and friction. You start to look into friction. So in SPM, you deal with friction also. But in this module, in the university level or degree level, you look into more deeper dimension of friction. Okay, so this one is test 1, question 2. Then CL3, CL4 will be in your test 2, question 1, question 2. So CL3 is about what you learn in CL1, CL2, you apply in application in daily life. For example, truss, frame, machine. This one is in your civil and mechanical application. So I think if you're civil, you already expose yourself to truss and frame. So mechanical, you start to expose to machine. Okay, so CL4 is you look at center of gravity and center of mass. So in this module, try not to confuse between center of gravity and center of mass. One is CG, one is CM. So in your secondary school level, you assume these two is the same. These two at the same location. But in this module, these two split, these two in different location. So this is the difference between your secondary level and university level. So don't confuse with this one. And some inertia and all this. And then what happened to your final exam? Final exam, question 1, question 2, question 3, question 4. 4 questions. Okay. So your final exam will be 100%, 25 mark, 25 mark, 25 mark, 25 marks. Test 1 will be 25 mark, 25 mark, 50 marks, convert to certain percentage. This one also 25 mark, also 25 marks. So it will be that. So we were focusing on these 4 learning outcomes throughout the semester. Okay. The rest you read. The rest you read. So this is my full name. I'm Dr. Ang. So my room is at the center. If you go to the this block as a center row, inside one. So this is my email. I'm not sure whether when I send Canvas announcement you see this one or not. Okay, then this is my phone number. Since last semester I stopped creating WhatsApp group because I found it is not very effective. So I didn't use the WhatsApp group anymore. But if you need help, just go to my room. My consultation hour is lunchtime. So if you need anything, just drop by. Just save my number, WhatsApp me. When you WhatsApp, please introduce yourself. Hi sir, I'm student from what class? And then you ask whether I can see you what day, lunchtime or anytime. If you think you need to see me, then you WhatsApp me. Okay. Don't WhatsApp me after office hour. Saturday, Sunday, you do your own thing. I do my own thing. So don't disturb each other. Don't disturb. Okay. And then don't, especially when come to test or final exam. Some of you will tend to text me. So what is the area of is this coming out or not? So usually I'll give you tips before the final exam. Don't worry. Okay. So this is my phone number. Right. So right. And if you want to know about me, just Google my name. You can see most of my information there. Okay. All right. Now, how we see also? Actually, there are 4 class clashes. So yeah. So you need to check with the. I think at the moment just find any class. Then we talk to the tabling. Actually 4 class clash already. Supri also. Then another lecture. Okay. Yeah. Okay, this is how we access your performance. You break into coursework and final exam. Will be 40, 60. So this is your second semester. You should be familiar how we judge you. So test, we have 2 tests. Each test will be 10%. All right. So I already cover how we ask you the question according to the learning outcome just now. Then individual assignment 10%. This one is 10% free mark. Means that I will upload the question maybe week 8, week 7 or week 8. You submit in week 13. All right. This individual assignment for your info, it will be from our lecture notes. The answer will be there. So it's only you get 0 or you get 10%. Or some of you careless mistakes, you just copy 100%. Because in my lecture notes, in my PowerPoint slides, sometimes I purposely put the wrong answer. Sometimes positive, negative, I purposely put, and then I'll ask you, is there anything wrong with the answer? So if you copy directly, some of you won't get 10 marks here. So just pay attention to the details there. Basically, most of the students will score at least also 8. But if you forget to submit, then 0. Okay. Lab report 10%. This module, this semester, will lead by Dr. Abdul Reza. You know who is he, right? So lab session will handle by Dr. Reza. All the lab report will submit to him. But again, in our class, I'll still brief you how to or anything that you need to aware. This one. So this 10% will mark by Dr. Reza. Okay. Okay. There are 7 or 6 experiments you need to do. Okay. My style, usually I will just spend 2 lab sessions and then you do all the experiment in one go in week 7 or week 8. Then you generate the report. However, Dr. Reza's style a bit different. You need to go into lab in week 3. It's week 1, week 2, week 3. You need to go to the lab and meet Dr. Reza there. Okay. So anything related to lab, we will go to Dr. Reza there. His office is in this row also, but is facing the corridor. Right. Final exam 60%, 4 questions. Passing criteria, you need to score 40 out of 100 in final. And the total marks means this one, 40 plus 60, you combine, you need to get total 50%. Right. Try to score high in your tests, 2 tests there. Lab report, it depends. It depends how you write, but the format is there. Okay. I'm not sure how Abdurreza judge your report. Usually I'll just give chance to you, but it depends on him. Okay, so there are 11, yeah. Okay, okay. So there are 11 chapter. There are 11 chapter there. So tentatively, we will do test 1 around week 7 or week 8, which is after your Chinese New Year festival break. Okay, so test 1 will be around that time. And then we will do test 2 in week 13. Week 14, last week, we will do revision. We'll do a lot of revision discussion. Usually, week 14, I will not very strict in your attendance. If you think you don't need, then you don't need to come. But if good, you come. If good, you come. All right. For this module, or I think for most of the module, you need 80% attendance. 80% attendance. How they calculate a bit weird. Let me. You have 14 weeks. Right? Week 1 until week 14. Okay, each class each week you have lecture and tutorial, so 2, and lab also 1. 1 here. But lab you have 2 hours lah. Okay, we count by hours. Lecture and tutorial you have 3 hours. Lecture 2 hours, tutorial 1 hour. Right, 3 hours. So usually attendance will be this one 3 times 14, so you get the number. Here every week also have, but this one sometimes we don't consider a lot, but sometimes if you have a very weak attendance, then they will look into this one. Okay, so 80%, how they count is not through week 1 to week 14. So week 1, you have 3 hours, 2, 3 hours, 3, you have 3 hours. So let's say week 4, 3 hours. So here got 12, right? So if you miss less than, if your attendance less than 80%, you're prompt warning already. Yeah, if you miss anything, 12 multiplied by 8 is what? 1.2 times 2, 2.4. So means you miss 1 class or 2 class, or means this one 2 hours and 0.4 hours. Because 1 week you have 3 hours. If you miss one lecture, one tutorial, you will be prompt attendance less than 80% at week 4. Okay, so as is move on, you accumulate this one, you will time 80%. Okay, so if you do well up to like maybe week 10, it should not be any problem anymore. Okay, so don't come and ask me, sir, why I keep getting warning from you and so on. Yeah. Lab is week 3. Start from week 3. Start from week 3. Because this one handled by Abdul Reza, so I don't disturb his work. But in terms of lecture and tutorial, if you miss class, then you'll receive some email from me. Okay. Okay, so in our class, lecture and tutorial, what consider late, what consider absent, I already write in the Canvas announcement. If you come in for 15 minutes or 10 minutes, I forget already. 15 minutes, you consider late. After 30 minutes, we start class, you consider absent. I'll mark you absent. You still can come into the class, you still can continue joining the class, but in the TCMS, I will mark you absent. Okay, then you'll get warning by the week 4. Right, so this is how we do. All right, if you are sick, please get MC. Give the MC to me. You know you have my numbers already. You WhatsApp me on the same day. Get the MC. WhatsApp me. Take photo. WhatsApp me. If you're hospitalized, maybe you are not conscious, so maybe you take 3 days to wake up. So you WhatsApp me when you wake up lah. Not my issue. Not my issue. Okay. Okay. So, but anyway, this is just my guidelines. Because we have 2 hours, usually we will have 45 minutes. Then we break. We continue another 45. We don't go straight 2 hours. So I give chance lah. Sometimes I give chance. If you miss the first session, I'll still give chance. But second session, you still didn't come, then absent. Okay. So that is the flexibility in our class, right? So this will be the course reference. As you can read from the Canvas also, I upload the course structure, but again, it's too many information. So these are the few reference books that we have. But anyway, if you're able to follow our lecture, you're able to understand what we're talking about in the class. Basically, you don't need to go to the textbook. Okay, so make sure after each class, you're able to understand what I'm talking about. If you don't understand, stop me. So I don't understand this one. How come this one? Okay, so some of you are in the second semester. You still haven't adopted to how university works. The way you study, you need to change a little bit. When it comes to engineering dynamic or statics, the way they ask you is not from memorizing. Is you need to answer why and how, because we are training you to design something. You need to understand at what case I apply this equation. And you have 11 chapters. Each chapter have its own equation. So when it comes to like test 1, CaO, CO2, I'll give you the scope. I'll give you a scope like chapter 1 to chapter 4. So you only need to remember like maybe 8 equation, important one. So don't use other chapter equation in the test 1, for example. So chapter 1 is basically is a revision. 50% is the revision from your physics class, right? What is units, SI, how you write engineering value in the answer and so on, right? What are the careless mistakes that usually we see when it comes to engineering dynamics class or higher level module? So we try to fix that at statics level. So you don't miss mark or careless mistakes marks in this one. So these are the things we will cover, but we'll go one by one. We try to go a little bit. Maybe today we end at 9 o'clock, or maybe before 9 for today. Right, then we continue our next class. Our schedule, just to check, our schedule is every Monday, 8 to 10. Then your tutorial will be Tuesday, 8 to 9, right? Then your lab session will be Wednesday. Wednesday, is it 12 to 2, right? Make sure you have this one. So I think we don't change our class schedule at the moment, right? So it's just, although it's a bit early lah, but still okay, right? So we just do a little bit of revision on what is the physics chapter about. So this on the first week, we look at basic quantities, mechanics. Oh, by the way, if you go to Canvas, you will see a tutorial question in chapter 1. That actually is revision material for you. It actually go parallel with my lecture. Means like if you go to tutorial question 1, tutorial 1, chapter 1, question 1, you will see my slide number 3, that one. I will talk about that particular things. So you go parallel. So you can write something on the tutorial question, right? Yeah. So that is part of the learning tools, because we have a few types of learning style. One, some of you might be audio. You're audio learners. So audio learners, you come to class, even you close your eyes, you also understand what I'm talking about. So that one, you can look at the video recording, which I will upload into a YouTube channel, and also I'll copy the link into Canvas. So just view it after the class. Some of you are psychomotor. You need to write something to remember. So the tutorial question actually is catered for the psychomotor learners. You need to write something, right? So it's that one. And again, the tutorial question that you see now is version 1. I'm still developing the things, right? Because the module was assigned to me last week. I only know I teach this subject, right? Okay. So these are the things, and we'll look into Newton laws that you learn into physics, right? Unit SI, and how you solve for problems in engineering. Okay, now we start to look into mechanics. What is mechanics? Mechanics, we look at how the body performs under forces. Mechanics is actually how the body performs when you give some forces to it. So for example, these cars and these cars, they actually it can be static, although static means doesn't move. So if this lorry do not move, this car do not move. However, there are some mechanics happen on the cable because of the car weight, car mass, right? And something happened to the bodies. This is internal force. So you will solve this one in later chapter. Okay, so anyway, we will look into forces most of the time and what happened to the bodies. You need to answer what happened to the bodies. You find answer negative, what does it mean? You find answer positive, what does it mean? Okay, so before we go deeper, in general rules, X and Y axis, or things that move to the left, we will give positive sign. Things that move up from a reference point, we give positive. In general point. In some special case, we will skip this procedure. We will do modification a little bit, but in general, 80% question, you follow these rules. These are things. So for example, you find at the end, you get negative, means something is different from the normal direction. You need to tell where does this object go, for example. Okay, so positive, negative is important for this module. Don't simply anyhow assume it's positive. Sometimes, or can say most of the time, we will trick you. We will set a question that your brain will think is positive. Actually, it's not. It's negative. So just pay attention to it. Okay. So there are type of bodies or mechanics. First one is rigid body mechanics, right? Again, what is mechanics? Is something happen to the body when you give the force, or something happen to the body when there is an action of force. So rigid body, something like this. Rigid body means it cannot change shape. Rigid means rigid lah. Means it's a. So these are the two rigid body. This is a gear. This one also gear. So these two, how these two move, or how the energy or forces transform from one body to another one, because they are rigid body. So when they are rigid body, means they 100% transfer of energy from one body to another one. Okay. Second one is deformed body, deformable body, for example, spring. So as we go deeper and deeper into a further chapter, we'll look into deformable bodies. For example, you'll start to see spring structures in the question. Okay, so spring structure means something you give force also, but something it will not go linearly with the bodies sometimes. So this is a deformable mechanism. Float, you know lah. Float is like water. It's something what happened inside the pipe and all this. For statics, you only see this one in the last chapter. To look into float mechanics. Okay. Right. So this one you read lah. When you read. Most of the time you deal with rigid body in this module. Okay. So rigid body, you have two areas. Now you take statics. Next semester, if you pass statics, you go to dynamics. Okay. So what is statics? Again, the keyword I highlight with the green color. Statics always deal with constant velocity. Okay. Constant velocity. In physics, you have distance, right? Distance from point A to point B. In dynamics or statics, we rarely use the word distance. We use displacement. Okay. So you know what is velocity? Is a chain of displacement and time. There's a difference between triangular and the symbol D. ds and triangular S is different. Delta D, also we call it delta, or okay, delta ds means small changes, very small changes that you cannot measure by normal instruments. Too small to measure, but there's a changes. D means something that you can measure with current instruments. Right? Yeah. Boleh? Tak ada power. Tak ada power. Okay. Okay. So then you learn mathematics, you turn this partial differential into D, right? You learn about limits, right? T, you go into 0 or infinity. You change this one to this one. Right? You learn this one in mathematics 1, right? Or 2. 1, I think 1. Okay. But anyway, I will assume you already know all these things, right? So velocity is a change of displacement and time. What is acceleration? We use A, is the change of velocity and time. So this is not divide, it's a differential. Okay. Try to differentiate what is divide, what division, or divide with differentiation. Differentiation a bit different. Okay, so And in statics, the keyword highlight in green color, constant velocity. When you have constant velocity, what happened to your acceleration? Zero. Huh? So for statics, you already know your acceleration most of the time is zero. However, next semester, if you take statics, take dynamics, most of the time it's not zero. So if you find your acceleration got some value, then you need to think twice. This one normally, if it's not zero, then maybe it's a later chapter. Maybe test 2 kind of level. Okay. When we talk about energy, talk about momentum, and then this one. But again, we rarely go into acceleration because you will get zero. Anything you substitute zero, you multiply, you get zero. You still come back to the zero answer. So it won't help you to solve. Okay, so again, acceleration is zero. Okay, so this one is important because why? We have seen careless mistakes happen when students they confuse with what is statics question. They try to find acceleration. Most of the time, you need to find velocity. Yeah, you need to find what is the velocity and not acceleration. Okay. So in physics, also know what are the basic quantities: length, time, and mass. This module also, there's a difference between mass and weight. Mass unit is kilogram, weight is in Newton. So when you answer or when you give us your solution, try not to confuse between these two. So this one you know, length is what you see on the screen. Length. Okay, so there's a standard way we write length is in the unit of meter. Time is a succession of event. So means what happened at a certain time. So in statics, when you plot graph t versus something, so you need to know what happened inside the thing. So you monitor what happened to the time there. Okay. Okay, mass again. Mass is a quantity of matter. Is a quantity of matter. So it's in kilogram and not Newton. Newton, it become force already. Okay. So these are the few basic quantities that you will see most of the time: length, time, and mass. So length, usually we use L, or sometimes we use capital L. Mass, we use capital M, or sometimes we just we use small m. Weight, we use capital W. Time, we use second. Time, we use second as a basic unit. Okay, these are the a few things. Force, again, force is a derivation of these few things here. Right. Of course, in this module, I won't ask you definition anymore. Definition in terms of in your answer, in the form of equation. In this engineering statics question, when you answer, most of the time you answer using equation. For example, F equal to ma, for example. Right. Now this is just a revision. What is force? Force is push and pull on the body. Right. Okay. Force. So there's another things before we move on. There is a call scalar and vector. Scalar is a magnitude Magnitude means the magnitude. So for example, length is 2 meters. So it's scalar unit. However, when it is a force, force is not scalar anymore, it's a vector. Vector have two things, magnitude and direction. So this one only have magnitude. Or in the later slides, you will see I will give something, for example, you will see some symbol of this one. It means find the magnitude. Here, you will see magnitude and direction given by angle. Okay, so this one in your SPM or secondary school, you stop here. But when you study at university level, you need to assume you are actually dealing with vector rather than the scalar, right? You derive the scalar from vector. Vector, you have magnitude and direction. Okay, these are the things, right? So force is a vector. So later we'll look into the deeper equation. Okay, what I mean by idealize? Idealization means we simplify the way we see question. For example, the car just now, the car with there are two cars, one lorry, one car on the lorry. We simplify the question in three ways. It depends on the chapter you're going in. The first few chapter we solve by using particles, means we look the lorry, right? The lorry and the car. These two that we see, I show you just now. This one as particles, one dot. Okay, means we idealize, we simplify the question by saying this one as one body. Not cannot say body. It's one dot, or we call it particles. One dot. Second approach is we see this one as rigid body. This one have two rigid body. We see this one as one rigid body also can, two rigid body also can. It depends on what kind of situation you want to solve. Okay, first is one dot or particles. One is rigid body. It depends on how detailed you want to solve this question. If you deal with internal energy, then this one become two. So in general, chapter 1, 2, 3, this one you assume as one. What mean when you assume as one? You look at, you see this one as the dotted area lah. When you solve question, you solve by this one. You see as one rigid body. Although there's something happen inside there, but you see as one rigid body. Sometimes when you solve equation, we will again further simplify this one using basic form. You can use any form you like, basic shape that you like, but as long as you use shape lah. Okay, why I highlight this one? Because some of your senior, they don't know how to represent a question in a diagram called free body diagram. Later I will you learn free body diagram in your civil or right. So still some of you are still weak in converting the bodies, the bodies into free body diagrams. So free body diagrams, sometimes you can use dot, sometimes you use shape. Particles means you see in the dot, sometimes this dot you need to enlarge, become one big dot. Means you sum as one things. Then concentrated force is that you know that this body have lots of force. Lots of force acting on the body. Concentration means you sum all the force become one. Okay, one basic structures that you see in construction. You see wire, right? This is a pole, then this one is a electric wire, right? So this is wire A, B, C, D, right? So there's a force pulling the four cable. But anyway, when we do idealization, we see the pole is actually having one concentration force. Something like this. Okay, so force A, force B, force C, force D become resultant force. So in simplified the design, so you only look at, you don't need to look at the cable, you only look at the structure itself, what happened, how many force you need at this point, for example. Okay, so these are the approach that normally we use for particles, rigid body, and concentration force. Right. So the rest you read, The rest you read. This one, particles, for example, you study about planets and so on. You look at each planet as one dot. Okay. The rest you read, We doesn't care about the geometry when you do particles approach. The rest you read. Particles, we still look at the mass. They still have a m there, mass. The effect of mass still there. The rest you can ignore. The size you can ignore. However, when it comes to rigid body, size does matter. When it becomes rigid body, size does matter because you start to look at inertia. So, for example, the ring with three pulled by three forces here, right? So this is elastic. This one is the normal rope. So you have three forces acting on the ring. You can represent this diagram if you do particles. If you study ring, what happened to the ring? You just draw forces, F1, F2, F3, for example. Okay. But if you do rigid body, then different already. Rigid body, you need to look at the ring, find the IXX, IYY. You seen this one before? No, not yet. Okay. The later chapter, we look at what is this one. By the moment, I just show you what is particle. Well, rigid body, this one you read again, is a combination of particles. So for example, this Grab driver, you have motor, you have bodies, you have the luggage. So if you do rigid body, it can be one as whole, or if you want to study the internal energy, means the body acting on the cushion here, then you use a rigid body approach. You break this one into two bodies and you solve. Okay. This one you read. Rigid body, the word rigid means the shape doesn't change. This one, the shape doesn't change. So again, repeat. Particles, what still matters? Mass still matters. The M still there. Size doesn't matter. But when you solve rigid body question, mass matters and the shape matters. Sorry. This one is the combination. Shape doesn't change. Shape matters, but the shape doesn't change. Okay. This one you read. Concentration force. So this one is a real wheel acting on the bar here. So we can represent what happened to the force acting on the bodies. Concentration force, the keyword here is you look at one point on the bodies. One point on the bodies. So if you look particles, means the force pointing or pulling from the particles. If you do rigid body, the force is pulling or pushing. At the point of the body. Point, this point, this point, this point, this point. Okay. So when you do rigid free body diagram, you need to label what are the points you're focusing on. What are the location you focus on. So these are the careless mistakes. Usually in the question, you draw the wrong free body diagram. You put the wrong location of the force, or some force is missing. Okay. This basically there are three idealization. You see the question as particles, you see the question as rigid body, and then you solve concentration force on the particles and rigid bodies. Okay. Newton laws, three Newton laws, as you learn in your secondary school. You have three Newton laws, right? Right. Three Newton laws. They are observed based on experiment. And again, they are true non-accelerating reference frame, meaning constant velocity. Okay. So first law, this one you read. It means if the object is at rest, you remain at rest. If it continue to move, it will continue to move. This one you just remember the first rule is if it's continue to move, if it move, then continue to move. If it stop, then it will remain stops. Okay. So I didn't bring the toys in our first class, but if you're interested, you can go to this link. Let's see if I'm able to open. What mean by the first law? Means this guy try to use a bat to knock this one. The focus point is not this one. Focus point is this tennis ball. When you hit this one, this tennis ball do not follow the motion of the bat or the motion of the glass here, but it will remain at here for some time, then it will drop because of gravity. That is first law. Okay, so I think you have this one in your secondary school. Okay. And you might see this one in your lab also, lab session, right? This one you go and watch. There's a link there, you go and click and play with it. Second experiment, not experiment, but second games that I didn't bring the cards and all this. So usually you see some magic tricks. You have lots of bottles, then the people pull the cloth away. That one also first Newton law, right? Because if you pull fast enough, the glass will remain at its position. That is first law. So this one also same, right? So if you're interested, you can go and buy a balloon and put some coins there, and you try to rotate the balloons. The coins will keep on rotating inside the balloons. Quite interesting. That is the first Newton law games. Okay, so again, first Newton law is one is stop, it will stop. One is move, it will continue to move. Second Newton laws. Okay, second Newton laws basically is core of this subject or the core content of this object. We apply force equal to ma. All this you read, all you read means you sum up all the force, it will give you acceleration. Mass doesn't change. Mass do not change. There's no change in mass in this module. No matter how the form is changed, the deformation happen. If you do tensile test or any test, compression test, the mass still same. Don't go and change the mass. Okay. Acceleration. So F equal to ma. Again, this module deal with a constant velocity. So what happened to acceleration? 0. When this side is 0, all the force equals 0, that actually is an equilibrium equation. Means you solve all the force equals 0. Means you combine all the force inside your free body diagram equals 0, you solve the missing parameter. Okay, so that is the idea for statics. Okay, so this one is see the effect of mass, right? While using these simple games. There are two balls with a board here with a slanted angle. So when you put something, this ball will glide and hit something. Right? So this ball is heavier than this ball. So when you use the white ball, you roll, this one will hit and then it will bounce at a certain distance. This one is lighter than this one. You hit this one will bounce a little bit shorter compared to the previous one. So this is a few games that you can play to prove second Newton law. F equal to ma. Okay. So of course there are more sophisticated experiments that you see in the lab session. Okay. So your lab session, you deal with these three laws. You need to write your discussion based on these 3 Newton laws. Explain what is first Newton law, second law, third law. So this one, another one. So this one is you spin something. You spin something. You tie an object with a rope. You spin something. You spin. You let go. The object will fly in a straight line. Fly in a straight line. Also, prove first Newton law. Object that continue to move, you continue to move. Right. Second one, F equal to ma. So this one mass. The more mass you do, you'll feel more force at your hand. Here. So the object more heavier, then you'll see some force here. You'll feel something in your yeah, something like that. Third law, opposite. The law is opposite, right? Third law is talk about action and reaction. This one is inside our module also, but in later chapter. This is when we talk about internal forces, what happened to the internal. For example, these two cars, what happened between this relationship and this platform here. We talk about this one. So the third law is there is a action and reaction. A very famous experiment is balloon. So you blow the air inside there, right? The balloon. So the mass of air there. When you let go the air moving this direction. So there's another force that is pushing to the front. This explains the third law. Okay, so this is another the 3 experiment. So the three Newton laws are first, second, and third is important when you solve question for statics. So you need to remember what is first rules, second rules, and third rules. And each chapter will link to each of the Newton laws. Okay, the third one is maybe 2 more minutes, then we stop. Okay, we have covered Newton laws. The third one, which we rarely use for mechanicals and civil, which is the law of attraction. I myself, I graduate with a mechanical aeronautics engineering, master's in aerospace engineering. Right. My PhD is in mechanical, but I did rocket science, rocket projects. Right. So this one deal with law of attraction. F equal to G M1 M2 R1. You don't need to remember this, memorize this one. This is just to let you know in fundamental concept, there is an equation called for the law of attraction. When you have two bodies, then you have this equation. This one is important if you study astronomy, right? Astro or aerospace engineering. What is important? You simplify the whole thing into weight. This one, okay, so you have this equation, F equal to G. G is the gravitational pulling force, two mass and the radius. So let's say you have two mass, one is particles, one is earth. Means this earth is one, and then there's a particle on the earth. Okay. So means this one is earth, this is this is sun, this is earth, this is you. So you take this earth as mass me. This one you replace one of the mass here with me. Then the mass of the particles as m. So this equation become m and me. R is the distance. Depends on what object you refer to. So this one, in this case, you're referring to these two bodies. So the R is here. Then there's a G. So you can write W equal to mg. So the G, right? The G actually is G me divided by R squared. On the Earth, for this module, start using 9.81 in your calculation from today onwards. Same with dynamic class, right? Don't use G equal to 10. Don't use this one. If you use 10, straight away give you wrong answer. I'll just put a cross there. Start from today, use 9.81. Okay. Right, so I think this is the first equation. Second equation, let's now you see F equal to ma. Second equation, W equal to mg. W is weight. Weight is the vector. Vector have magnitude and direction. So on the Earth, all the weight is pointing where? On Earth? Pointing where? To the center of the Earth. So if you draw a free body diagram, the center of gravity always look for the, central gravitational force always pulling from the center of mass. M, center of mass to the ground that give you weight. Gravitational force is G, but we rarely put G inside our diagram. Diagram will deal with force only, force and velocity. Okay, so these are the things I need to highlight for today. Yeah, maybe a little bit more. Unit SI, you know, right? So unit SI, mass, meter, second, kilogram, and so on. So Newton, if you write in unit SI, F equal to ma, the equation you learned today. Force is Newton. Have you learned dimensionless analysis? No. Okay. Mass is what? Kilogram. Acceleration? Meter over second square. You combine these two, you get this one. Okay. So this is how you solve question in statics. You sometimes you need to break this one into this one. Okay, and start familiar with the symbol dot here. In next lecture, we will talk about this dot. The rest you read, The rest you read. This is a conversion from US systems imperial system into unit SI. We will not use this one throughout this module. This is for your info. Just in case you work in the US later, or you have a student mobility program, you study there for one semester, then this will be the very useful chart for you. Okay, maybe we stop here. I'll see you tomorrow for tutorial. So make sure you sign your attendance. You sign attendance before you go. Stop here.